Okay, in this next group of videos, we'll go over some multiple choice questions related to limits and continuity. So we have this piecewise function, f of x is square root of 2x plus 5 minus square root of x plus 7 over x minus 2 when x is not equal to 2. And then when x is 2, then f is equal to k. And so obviously from the first branch at x equals 2, that expression is not defined. And so if this is a removable discontinuity, then we should be able to redefine f of 2 is equal to something to fill in that hole. And so we want to find out what is the value we use to fill in that hole. And that value that we use to fill in the hole would be the limit of that expression in the numerator there. Remember, the limit has to equal the value of the function in order to be continuous. And mathematically that looks like limit as x approaches c of f of x is equal to f of c. Well, because that first branch, that top branch, covers all values to the left and to the right of x equals 2, so that's where we would find our limit. So we're starting off with limit as x approaches 2 of square root of 2x plus 5 minus square root of x plus 7 all over x minus 2. And this is a radical expression, so we want to rationalize. We want to rationalize the radical expression, which is in the numerator in this case. And so we're going to multiply top and bottom by square root of 2x plus 5 plus square root of 7. And when we do that, we multiply the numerators. We're going to get first term squared minus second term squared. We have a limit as x approaches 2 minus x plus 7 all over x minus 2 times the quantity square root of 2x plus 5 plus square root of x plus 7. Now we're going to simplify our numerator, and that's 2x plus 5 minus x minus 7. So x minus 2. And we're going to use that to cancel with the x minus 2 factor in the denominator. And so we have square root of 2x plus 5 plus square root of x plus 7. And we cancel the x minus 2's. We'll be left with a 1 in the numerator. And at this point we can plug in x equals 2. 2 times 2 is 4 plus 5 is 9. Square root of 9 is 3. 2 plus 7 is 9. Square root of 9 is 3. And so we're going to get 1 over 3 plus 3, which is 1 over 6. And the selection would be B. Okay, we'll go on to the next problem. Okay, we have limit as x approaches 0 of 1 minus cosine square of 2x over x squared. When I see the cosine square, especially 1 minus, that tells me that this is using my Pythagorean identities. Sine square x plus cosine square x equals 1. So 1 minus cosine square of x is equal to sine square of x. So the numerator is going to become sine square of 2x over x squared. Now we're going to need to split this up. Limit as x approaches 0, sine of 2x times sine of 2x, and we have an x squared in the denominator, so we'll put them under each of the sine of 2x's. Now we still can't make those 1 yet until we have sine of 2x over 2x. So we're going to have to multiply top and bottom by 2 in both cases. Then the sine of 2x over 2x is going to become 1. So just rewriting it so that it's clear, you're going to have sine of 2x over 2x, that becomes 1. The limit as x approaches 0, of course. The actual value is not defined at 0, and it has very different values for other values than 0. And so we're going to get 2 times 1 times 2 times 1, which is 4, or option E. We come to problem number 3. We have the limit as n goes to infinity of 4n squared over n squared, and so this is a limit at infinity, and because the numerator and denominator have the same degree, we just simply divide numerator by denominator, and we would get 4. And so that is option D. In problem 4, we have limit as x approaches 0 of x times cosecant of x, but cosecant is just 1 over sine x, and we have seen previously that the limit as x approaches 0 of x over sine x, just like sine x over x, is 1. Option D, and that does it for this video.